This is Geometry Unit 11, Lesson Number 1, Perimeter and Area of Polygons. Now, if we're working with perimeter and area of polygons, we have to understand and remind ourselves what perimeter and area both mean. So the perimeter is the distance around the outside of a figure. So if you're going around the outside of a figure, all you have to do is add the sides. So the perimeter of any figure, all you have to do is add up the sides. So this polygon, we would add S1 plus S2 plus S3 plus S4 plus S5 plus S6 to get the perimeter. All of the units would be the same, we just add up the outsides. Now, to find the perimeter of quadrilateral ABCD, we'd have to add all the sides of the quadrilateral. AB plus BC plus CD plus DA would be my perimeter. So, if we have on coordinate plane horizontal and vertical lines, they're easy because we can just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for AB. And BC is a nice vertical line, 1, 2, 3, 4, 5. All right, now the problem with AD and CD is they are slanted. But the nice thing about that is we can actually square them off and make nice right triangles. So I'm going to square this off like this. Now that is going to make a right triangle with this as the hypotenuse because these are vertical and horizontal. That would make this 4 and this 4, and that makes CD my hypotenuse, so I could use the Pythagorean theorem. So that means 4 squared plus 4 squared is equal to CD squared. 16 plus 16 is equal to CD squared. And that means that CD squared is going to be 32. So CD is going to equal the square root of 32. If you put it, I'll leave it in that form for right now. So CD is going to be the square root of 32. All right, so this BC is 5, CD is the square root of 32. And we can do the same thing with DA. If we look at DA, you can either do it right here or up here at the top. It doesn't matter. We're just going to square it off and count it over. There's my right angle. This is 1, 1, 2, 3, 4, 5, 6, 7. 1 squared plus 7 squared is equal to AD squared. 1 plus 49 is AD squared. AD squared is equal to 50. So AD is going to equal the square root of 50. Okay. So my perimeter is going to be 16 plus 30, square root of 32 plus the square root of 50. Now, if we wanted to round this off, we would have to enter this in our calculator. This is going to be approximately 28.7 if I round it off, say, to the nearest tenth. I just have to add these together, and I get my perimeter. So perimeter means to add up all the outsides. With horizontal and vertical, you can count. With slanted lines, you have to use the Pythagorean theorem and square it off. Now remember, the distance between perimeter and area is, perimeter is the outside, area is the space the figure's covered. It is the inside of a figure. It's how many squares would fill up a space, how many square units would fill up a space. So if I have a rectangle, how many squares are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, we can't always count every single square. So what we have to do is multiply the length times the width, because area is length times width, or sometimes it's called base times height. So we count 1, 2, 3, 4, 5 is the base, 1, 2, 3 is the height, area is equal to 5 times 3, and it is 15 square units. All right, because there are 15 squares that would fit inside this figure, so it's 15 square units. Now, all of our other area formulas we have are based on this formula base times height. If I look at a parallelogram, if I take this piece of the parallelogram right here, this triangle on the end where the height is, and I put it over here, what have I created? I've created a rectangle. And what's the area of a rectangle? It is base times height. So a parallelogram's area is base times height, which is the same as length times width. The only difference with parallelogram is the height is measured vertically from the two bases, base The base here is vertical. So the area, a parallelogram has the same area as a rectangle with the same base and height. So if your base and height of the rectangle is 5 times 3, the base and height of the parallelogram could also be 5 times 3, and it works out the same way. All right, now let's see if we can figure out the area of a triangle. You probably know area of a triangle for the formula, but where does it come from? Well, if we start with our triangle right here with a base and a height like so, if we rotate the triangle about its midpoint like this, don't we create a parallelogram? Yeah. So if this is a parallelogram, we've created a parallelogram, we know the area of a parallelogram is base times height, but we only have part of it. Well, if this is two congruent triangles, this is actually going to be 1/2 base times height. So a triangle has half the area of a parallelogram with the same base and height. So if we make this into a parallelogram with two triangles, each triangle is going to be half the base times the height of the parallelogram. All right, now here's a neat one, the trapezoid. The area of a trapezoid. So if we look at a trapezoid right here, we have two bases on our trapezoid, B1 and B2. Now, if we just take the triangle, if we draw in the diagonal like this, it's drawn right here on the triangle, this triangle right here, and rotate it 180 degrees. Well, we end up with actually two triangles. We have a triangle here, this triangle right here, right there is this one right here, and then you have the other triangle on the top. You have this triangle here, which is this one, and that's actually rotated 180 degrees. You actually end up with two triangles. So you end up with the area of this figure is going to be the sum of these two triangles right here. So we have the same height and we have two different bases. So that means the area is going to be 1/2 times the height times the sum of the bases. A trapezoid has area of the sum of the two triangles with the same height. So the two bases here times the height and then times 1/2 because they're both triangles. 1/2 times the height times the sum of the bases. So those are all the formulas that you need to know for area. They are written on your reference sheet, but it's handy to know where they come from. All right, so let's look at some areas in coordinate geometry. We want to figure out the area on a piece of graph paper, basically. So we want to find the area of a triangle. So this triangle right here, remember the formula for area is 1/2 base times height. Now, the base and the height, remember, have to be, the base and the height is from the vertex to the base. So your base on this one's easy because it's nice horizontal line, so we can count. 1, 2, 3, 4, 5, 6, 7, 8, 9 units. A is equal to 1/2 times 9. Now your height, remember, don't use the side of the triangle for the height. The height has to be measured perpendicular to the base, like so. So your height here is going to be 1, 2, 3, 4, 5, 6, 7. So your area is 1/2 times 9 times 7. And 1/2 times 9 times 7 is 31.5 square units. So this works out to be square units. Now, it says find the area of the figure which consists of 5 line segments. Now, this isn't any shape that we have. This is some kind of pentagon. We don't know all the lengths and the sides. However, it is made up of shapes that we could find the area of. Well, let's see if we can do a little dividing. The easiest way of dividing this is into different shapes. So what if I did, I'm going to make this, draw this line in right here, and I'm going to create a trapezoid and a triangle, because I have formulas for trapezoid and triangle. Now, there's other ways you could do this. You could also draw a line here and make a rectangle and two triangles, but however you do this, this is made up of the area of a trapezoid plus the area of the triangle. So we have the area of the trapezoid plus the area of the triangle. So to figure out the total area, we add the area of the separate polygons. So let's figure out the area of the trapezoid. The formula is 1/2 times the height times the sum of the bases. Okay, so 1/2 times the height of the trapezoid would be the distance from here to here, which could also be this side over here, is going to be 3. Okay, the bases, remember, on a trapezoid are the parallel sides. So I want the two parallel sides here and here. This base is 1, 2, 3, 4, 5, 6, 7, 8. And this one is 1, 2, 3, 4, 5, 6. Okay, so it's 8 plus 6. So the area of this is going to be 1/2 times 3 times 14, which is 21. And then I want to add in the area of this triangle right here. The triangle formula is 1/2 base times height, and since this is a horizontal and a vertical line, that makes this a right triangle, so we can count the base and the height. The base on this will be 1, 2, 3, 4 from here to here, and the height right here is 1. So it's 1/2 times 4 times 1, which is 1/2 times 4, which is 2. So the area of this figure will be 21 plus 2, which is 23 square units. So if you have an unfamiliar figure, see if you can divide it into separate shapes that you can add their separate areas together. So I did the area of the trapezoid here, area of the triangle here, and then added them together. All right, let's do the last one. All right, find the area of the triangle. Well, we know the area of the triangle is 1/2 base times height, but the problem with this is my base and my height aren't nice horizontal or vertical lines. So what could we do to find the base and the height? Well, we can do a little sneaky work on this. We can take each side of this and square it off. So I'm going to take this and square it off. All right, I'm going to each vertex as far out as I can so that I just touch one place on each one. Okay, now that makes a nice, on this particular one, it's a rectangle. So that makes a nice rectangle. Now, if I wanted to find the area of this part right here, and I found the area of the rectangle would be this entire space inside like this. If I found the area. So I'm just coloring this in. If I found the area of that rectangle that I just drew in, it would look like this. Okay, but I only want this in the middle to find the area of that. So I would have to subtract out the area that is not part of that. So I would have to subtract this, this, and this. And I'm left with the area of the triangle that I want. So what I'm going to do is find the area of the rectangle, and I'm going to subtract out the area of this triangle, and this triangle. I'll draw that back in. I'm going to subtract out those three areas, and I will have the area of the figure that I wanted. Okay, so the area of the rectangle, we're going to start out with that. That's the whole area. Area of the rectangle is length times width. 1, 2, 3, 4, 5, 6, 7, 8. Times 7 is this one. 1, 2, 3, 4, 5, 6, 7. So this is 56. All right, now each one of these triangles is 1/2 base times height. Okay, so we just have to find the base and the height of each one of these. All right, so this triangle 1 here, the base is 3 and the height is 7. This one, this is going to be, well, since this was 8 and this is 3, this one's going to be 5. This one is going to be 4, and this is going to be 3 right there. Okay, so filling those in, 1/2 times 4 times 5 will be this triangle, and this one will be 1/2 times 3 times 8. So this works out to be 56 minus 10.5 minus 10 minus 12, and your area is 23.5 square units. So we use subtraction from a bigger figure of one we could do and figure out what we wanted.